Hello friends, welcome back once again in the video lecture series of Theory of Computation. Today I am going to teach you a very important topic, that conversion from regular expression to finite automata, right? Here whenever we are talking about finite automata means here I am talking about NFA. That means if anybody talks about you finite automata is not DFA. Right? Finite automata is by default it is NFA. If someone will talk about DFA, it will specially comment on or emphasize on DFA, right? So please take note of that. Whenever we are talking about finite automata initially or elementarily it is NFA only. So basically I am going to convert regular expression through regular expression. I will teach you how to design NFA, right? So let us start of designing finite automata through regular expressions, right? So I have listed down some regular expressions. Although these are very simple regular expressions, so what is my mission is, first of all I will just design the finite automata with the help of simple regular expression. Later on I will show you how finite automata will be designed with some complicated regular expression, right? So let's start. So before designing the finite automata, let's see one example of finite automata, that is, this is your Q0 is your initial state, right? This is the second state Q1, this is the third state Q2, this is the final state Q3. Okay, can we have more than final state? Yes, we can have more than one final state like Q4, and this is also a final state. So in finite automata you may have more than one finite state, final state, not finite state, final state, but that will be only one initial state, right? And other than initial state and final state, all other states are known as your intermediate state, correct? So on this basis, let's start with these regular expressions one by one. So let's with the first example, that is epsilon. Epsilon means what? Without giving any input symbol, I can change my state. Say, suppose I am on Q0, and by giving any input symbol, without giving any input symbol, I can reach to Q1, and that will be your final state, correct? So it means that if I am not providing any input symbol and still I am able to change in the state, that means I am giving one symbol that is known as your epsilon. Are you getting my point? Without giving input, if I am changing the state from initial state to next state, and maybe next state is final state, that means I am giving blindly, you can observe, or blindly you can think that we are putting the epsilon symbol. That means this machine is known as finite automata for epsilon move. Now the thing is that whether this finite automata is simplified more or not, means whether we can reduce the state or not. Yes, we can do it. Let's see how. Suppose without giving any input symbol, if I am reaching to the final state, that means my first state, which is known as your initial state, can be considered as your final state. Please take note of that. Again I am telling you, if without giving the input symbol, if you are changing the state from initial state to final state, that means here I am using epsilon symbol, number one. Second thing is what? If I am putting epsilon symbol on any state and if I am reaching to the final state, that means this machine can be reduced from two states to only one. Correct? So let us consider about the second example. A is given. That means if I am on initial state, that is q0, and by applying a as input symbol, by applying a, I am reaching to the final state, that is q1. So sorry, your q1 like this. So this is your q1. So the equivalent finite automata for this regular expression will be, I am on q0 as an initial state. If I am applying a as input symbol, I am reaching to q1, which is my final state, right? Let's take the third example. For AB, we have to design 3 states, right? How? See, first will be your q0, okay, reaching to q1 by applying A and reaching to q2 by applying B. Sorry, this will be your q2 by applying B. See, for this third example, I am on q0. q0 is the initial state, and on initial state q0, if I have, okay, so just take this example AB. AB means what? This is the finite automata for AB. I am starting from q0 as an initial symbol, and on q0, if I apply A, I will reach to q1, right? And after applying B, I will reach to the final state, right, as q2. So for this AB, I will get what? This finite automata. Now this finite automata cannot be simplified because this is A followed by B, right? Come to the fourth one, that is your A star. Now for A star as a regular expression, try to generate the string. What will be the regular language for this regular expression? So I will get for A star I will get first epsilon, right? First I will get epsilon, second I will get A, third I will get AA, fourth I will get A, and so on, right? So I have already taught you, if any epsilon symbol is there, that means initial state will be your final state. Please take note of that. If any epsilon symbol is there, that means first state is the first initial state. Initial state will be considered as final state. Okay, this will be your final state. Okay, fine. This is for epsilon. Okay, this is for epsilon. Just I am putting the symbol here. And for A, what will be for A? For A, just take this one as A and q2. I will reach to q1, and this is also my final state. Okay, now AA, by putting AA, I will reach to q2, and this will be your final state. This will be your final state. By applying triple A, you will get one more state, and it will be your q3, and this will be again your final state. Now the question arises here, is this finite automata is not going to infinity? It is yes. This finite automata goes up to infinity if we are designing the finite automata on this regular language. But here the characterization or the characteristics of finite automata will be violated. Why it will be violated? That means कि अगर we will design such type of finite automata, that means surely we will goes to infinite number of state, which should be violated, right? Which should not be there in finite automata, because in finite automata we should have the finite number of states to represent any string, to represent any regular language. So can we do such type of thing that while going for the infinite state, we can take the finite state and we can represent all the strings? Yes, it can be possible. So for example, if I reduce this thing, if I reduce all these states and if I try to generate, try to apply these languages on this finite automata one by one, see whether it is possible for it or not. Say for epsilon it is right. Suppose I have to give A. So for A I will just put a loop, that is A. So how it will be read? Epsilon will be accepted. A for 1A it will be accepted. Looping for 2A it is also accepted. AA. Looping means you can take iteration as many as you want. So 1 time loop, that is it will generate A. 2 times loop it will generate AA. For 3 times loop it will be AAA. For 4 times loop it will be your AAAA. For 5 times it will be AAAAA. That means for A star this finite automata will be quite solvable. That means it will be very what I can say, this finite automata is suitable for this regular expression. We don't have to go for the infinite number of states, right? Next talk about this A plus B.